We're picking up where we left off in the previous video, where we were finding the domain of f plus g. The domain is going to include all values from 6 to positive infinity. Now, what does the sum look like? Well, the rule is we would divide 4 by x for f, and then we would add g. That's the rule for the sum. That's the easy part. The domain is what is a little bit more work for us to figure out. All right, let's take a look at the subtraction of f and g. We already know that the two domains intersect in the interval that starts at 6 with no upper bound. Here, we subtract the rule of f and the rule for g. And because we can't simplify any further, we can leave our answer like this. Next, we're going to look at what happens when we multiply f and g. Well, in this case, we take the rule of f and we multiply it by the rule for g. There's a couple of ways we could write this a little bit more concisely, but they all mean the same thing. The domain, again, is the intersection of the two individual domains, so we're still starting at 6 and going toward positive infinity. Now, when we divide f by g, this is where we have to be uber cautious. The rule for f is 4 divided by x, and the rule for g is the square root of x minus 6. Well, this is not a clean way to leave this, so I'm going to rewrite this as 4 divided by x times the square root of x minus 6. This is still not considered to be fully simplified, but it does look a tad better. The domain starts with the intersection, right, from 6 to positive infinity. But we also want to make sure that there are no values in this interval that would cause the denominator to be 0. And I do see one value that causes a problem. Looks like x can't be 6, because if x were to equal 6, then this quantity would be 0. And it's clearly in a denominator. So the new domain is going to start at 6, but 6 cannot be included. So we're going to use parentheses instead of a bracket. Let me make that a little bit more clear that it's parentheses. 6 is not included because the value x equals 6 would cause the denominator to be 0. Next, let's talk about forming composite functions. I like to think of having composite functions as having an entire rule for a function become the input for another function. The notation here looks like a little o in between the two function names, like f little og of x. But this is really pronounced f of g of x. And it's equivalent to having the entire function g of x become the input for the function f. So in other words, we would have to evaluate g of x first, and then whatever that result is, that becomes a new input for the function f. X must be in the domain of g, and then that result must be in the domain of f. Let's take a look at the following examples. F of x is equal to the square root of x plus 5, and g of x is equal to 8x plus 9. Then we have h of x is equal to 9 divided by x plus 5. Let's start with the first composition, f of g of x. So let's start with what g of x stands for, 8x plus 9. 8x plus 9 is our input for the function f. So instead of having x as the input, 8x plus 9 will be the input. So what is the rule for f? X is the input in its rule, but wherever we see x, we're going to substitute 8x plus 9. So f of g of x is going to become the square root of our new input plus 5, where the new input is g of x. Okay, so now we have the square root of 8x plus 9 and then plus 5. And of course, we can simplify this a little better and write this as the square root of 8x plus 14. So again, 8x plus 9 is the new input. Instead of x, we have the entire g of x feeding into the rule for f. All right, I know this is a bit confusing, so if you have to pause and rewind, please do so. If you want to look at the next example, then stay with me. All right, now we are going to compose the function f with itself. So the rule for f is that we take the square root of the input plus 5. But now the input is the entire f of x function itself. So we have the square root of the square root of x plus 5 and then plus 5. I know that this seems rather confusing, but basically you're substituting the second rule that appears into the input of the first rule. Now we could do some algebra to simplify this expression a tad, but for now we can leave it as we see it here. Let's look at our next composition. We have h of g of x. That means that g of x is going to be our input. Let me erase what I wrote here. That means that g of x is going to be our new input, and we're going to substitute that in where we see x in h. So let's write the rule for h. The rule for h is 9 over input plus 5, but for the input, we now have g of x. So this is equal to 9 divided by, well, g of x stands for 8x plus 9, and then we add 5 to that. So after we simplify, we get 9 over 8x plus 14. In this next example, we have 3 functions being combined, so this is going to take a little bit of careful work. First, f of x is going to become the input for g. F of x is going to become the input for g. We'll worry about h later, but we're working from the right to the left. So f of x is going to become the input for g first. So what does g stand for? G stands for 8 times input plus 9. Well, the input is going to be all of f of x. So then what is the rule for f of x? F of x is equal to the square root of x plus 5. So now we've taken care of g of f of x. Now all of this is going to become the input for h. All of that is going to become the input for h. So what is the rule for h? H is equal to 9 over the input, which is in this case g of f of x, plus 5. Well, g of f of x is what we found in the previous step. So this is going to be 9 divided by 8 times the square root of x plus 5 plus 9, and then another plus 5. running out of room here, but I can simplify this to be 9 divided by 8 times the square root of x plus 5 plus 14. All right, let's take a look at compositions where we have constants or fixed numbers for the input. Here we have f of g of 6, f of g of 6, f of g of 6. So let's find the value of the function g evaluated at 6 first. Look at the rule for g of x. It's equal to the square root of x plus 10, where x is 6 in this case. So that is the square root of 6 plus 10, which is the square root of 16, which is 4. So f of g of 6 is equal to f of 4. F of 4, let's look at the rule for f of x. That is equal to 12 over x plus 1. In this case, x is 4. So we get 12 divided by 5 as our final answer. In our next example, we have h of h evaluated at 1. So this is h evaluated at h of 1. Well, let's find what h of 1 is equal to. H of 1 is equal to 5 times 1 plus 5, so that's going to equal 10. Now we're going to use the value of 10 to find h composed with itself. So we're basically finding h of 10 now. So this new output becomes the input for h. And so let's go back to that rule. That's 5 times the input plus 5, so that'll give us 55. All right, hopefully you're getting the hang of it by now. Let's take a look at h of g of negative 6. So that's h of g evaluated at x equals negative 6. All right, so let's find g evaluated at negative 6 first. So if we look at the rule for g, we have the square root of negative 6 plus 10. So that's the square root of 4, which is 2. Now we're going to find the value of h at this new input at 2. H evaluated at 2 is 5 times 2 plus 5, which is 15. All right. One more to go. We have h of f of g of negative 1. So we have 3 functions composed, and in this case we have negative 1 as our original input. So the first thing we need to do is find g of negative 1. In that case, we have square root of negative 1 plus 10, which is the square root of 9, which is 3. Next, we're going to have f of g of negative 1. So that's f of 3, which is our previous result. And so f evaluated at 3 is 12 divided by 3 plus 1. 12 divided by 4, which is 3 again. And finally, we have h of f of g of negative 1. So we have f of g of negative 1 was 3. So basically we have h of 3. H of 3 becomes 5 times 3 plus 5. So that's going to be 15 plus 5, or 20.